Today we'll be looking at solving quadratic, polynomial, and absolute value equations. We'll start with learning the zero product property, and then some strategies for solving absolute value equations. Let's get started with an example. This problem just asks us to solve for x, given this strange equation here, which we should recognize as a factored polynomial on the left set equal to 0. So what the zero product property tells us in situations like this is that when we have multiple factors multiplying to equal 0, any one of the factors could be equal to 0. Before we use it, let's make some logical sense of what this is saying and how it works. So if we simply have a times b equals 0 here, then the zero product property tells us that either a equals 0 or b equals 0. Now what happens when we throw in one more factor, a times b times c equals 0? It's really just the same thing, except now a equals 0 or b equals 0 or c equals 0. So now we can go back and apply this to the polynomial we had before. And in the factored polynomial in our equation, which we see here, we have 4 factors. So each of those 4 factors could be equal to 0, and those will give us 4 different solutions for x. So let's go ahead and find each of those solutions. The first factor here is simple, just x. So we say that x can equal 0, which gives us the direct solution, x equals 0. Now the next one, x plus 2 equals 0, well, that gives us a statement which is an equation that we can then solve for the actual value of x that makes that factor equal to 0. So it might sound complicated, but it's just simple, and we solve that x equals negative 2 for the solution corresponding to this factor. And we can do that for the next 2 factors. X minus 2 equals 0 gives us x equals positive 2. And then lastly, x plus 13 equals 0 gives us x equals minus 13. Putting those 4 solutions together, our final solution combined is that x equals 0, negative 2, 2, or minus 13, and that will be our final answer. Here we are asked to solve a quadratic equation. We can recognize it as quadratic because we see the x squared and the x term, and then the term without x. Whenever we start solving a quadratic equation, the key first step is to get one side equal to 0 and everything else on the left. Then, and only then, when we have something equal to 0, can we try to use the zero product property to solve. So we'll start by doing that. First, we simply add over x to the other side, and that gives us the equation x squared plus 5x plus 6 equals 0, and like we wanted, we have 0 on one side, everything else on the other side. So now we want to use the zero product property, but we know that only works when we have a set of factors all equal to 0. Here we have separate terms, combined by addition. So how do we get from separate terms to one term with multiple factors? Well, that is the process of factoring, which you remember we learned in our previous video on quadratics. So reference that, and we will use those skills here. So to factor this, we'll use product sum, noting that the product is 6, sum is 5, and then that gives us the factorization of x plus 2 times x plus 3, doing it a little bit quickly. Now, those factors, using the zero product property just like we did a minute ago, are going to give us the solutions x equals minus 2 and minus 3, and that is our final answer to this question. Okay, but we got kind of lucky in that problem because we were able to factor that quadratic equation. What if we weren't able to factor the quadratic? What do we do then? Here we see the same exact equation that we just solved a second ago, except all we've done is change the 6 to a 2. But if you now try to factor this new equation, you'll find that you can no longer factor it using the product sum method. It just won't work. So what do we do when we see equations like this, quadratics that cannot be factored? Well, that is when we make use of the quadratic formula seen here. The quadratic formula allows us to find solutions, directly find the solutions, to quadratic equations that cannot be factored. So let's use that to solve this quadratic equation here. Let's now try to use the quadratic formula to solve a different quadratic equation, and we will see something kind of funky happen. So our coefficients here are just 1, 1, and 3, a, b, c, and we've plugged that into the quadratic formula, and we get what we see here. We're going to simply evaluate, and then we get negative 1 plus minus the square root of negative 11 over 2. But what's wrong there? We have the square root of a negative number. That is undefined. There is no solution to that. So when we're asking ourselves what is the solution to this quadratic equation, well, the answer is there is no solution, and that's all you can say. Let's put it all together. So whenever you have a polynomial, especially a quadratic, you first want to try to factor. If you can factor, then you can take that factored form and solve using the zero product property like we saw before. If you cannot factor and you have a quadratic, then you can solve using the quadratic formula, Just be sure to look out for when there are no solutions when plugging into the quadratic formula. Now on to our last topic of this week's video, absolute value equations and how to solve them. These are like quadratic equations in that they will always have two solutions. However, the process of finding those two solutions can be very different. Recall that the absolute value operation simply makes a number positive. So if you take absolute value of -5, it equals +5. If you take absolute value of +5, it still equals +5. So if we see an equation like this, the absolute value of x equals 4, then how do we find the solutions? Well, we have one scenario where what is inside the absolute value was negative, or the scenario where it was positive. So in this equation, this simply gives us x equals 4 or -4. All right, that was a simple scenario. Let's look at a more interesting example. Let's try to solve this more interesting equation using absolute value. So again, just like before, we need to split into the cases of what is inside the absolute value being positive or what's inside being negative. Now that gives us these two different equations, one equal to 2x, which is the positive case, and then one equal to -x. And now we need to solve each of these separately, which gives us the first solution of x equals -3. And then in the second scenario, we get the other solution of x equals 1. So our final answer here is that x equals 1 or -3. And those are the key points for solving quadratic, polynomial, and absolute value equations, all of which can have more than one solution for x. Next week, we will look at rational and radical equations, which also have more than one solution for x, but also have an added layer of complexity, which is what we call extraneous solutions.
Hope you liked the video. If you want to hear more and see what else we're up to, hit like and subscribe, and see a new video coming out from Point Avenue every week. If you want to talk to us, hear more about what we're doing, or have any questions, email us at contact@pointavenue.com. Bye!